Hello friends, in my last video I explained you structural isomerism. In that case, compounds having the same molecular formula but different structure formula, that is the isomers. Today I will explain you stereoisomerism. In the case of the stereoisomerism, the compounds have the same structure formula. Listen. In the case of the stereoisomerism, compounds having the same structure formula. In stereoisomerism today, I will discuss you geometrical isomerism. This geometrical isomerism is generally found in the case of the alkenes, that is double bond. Now here, compounds having the same structure formula and sequence of the bond, but differ in the spatial arrangement of the atoms or groups of the atom. Listen, compounds having the same structure formula and sequence of the bond but differ in the spatial arrangement of atoms or group of atoms about the double bond are called the geometrical isomers, and this phenomenon is known as the geometrical isomerism. See, if we take a example of double bond, carbon having double bond, and you know in double bond one is sigma bond and other is a pi bond, that is a cloud around the sigma bond, and this pi bond is formed by sp2 hybridization. Now for the rotation of the molecule at carbon atom, due to presence of this cloud, they cannot rotate. There is a hindrance. And to rotate, they have to overcome the pi bond or to remove the pi bond. And for that, they require a very high energy. So there was a steric hindrance. Now, what is steric hindrance? It was found that when the distance between the atom is less or equal to the van der Waals radii, then the atom they repel each other. Repulsion between the atom is there. So that is the steric hindrance. So due to steric hindrance, rotation at the carbon atom was not possible, and it was found as the number of the molecule increases on the carbon atom, this steric hindrance increases and that become more or less stable as compared to the other. Now, the two conditions are there for the geometrical isomerism. One is the molecule must have the double bond and the two atoms attached to the same carbon atom must be different. Two atoms attached to the same carbon atom must be different. Now I will take an example of the between. In the case of the first case, when the two groups of the atoms they are on the same side or the in opposite side. When the two groups of the atom they are on the same side, these are known as the cis, that is between. And when the two groups of the atom they are opposite to each other, these are known as the trans between. So here the structure formula is different. One is cis, other is trans, and it was found that the cis are less stable as compared to the trans. Now here you see two groups of the atom on the same side and the two groups of the atom they are opposite to each other. Now second example we take 1,2-dibromoethane. Here again two bromo they are on the same side and here it is the opposite side. So this condition is known as the cis 1,2 dibromethane, and this condition is known as the trans 1,2 dibromoethane. Now in the case of the isomers, it was found that they have the same chemical property but different physical properties. So this is all about the geometrical isomerism. It will be clear to you that in the case of the geometrical isomerism, compounds having the same structure formula and sequence of bond but differ in the spatial arrangement of the atoms or group of the atoms about the double bond are called the geometrical isomers. So if you like my videos, please share and subscribe. Thanks very much.